Hi, I'm Jay Fitzgerald. I'm a student in Chayton Coastal's lab. We work with Streptomyces bacteria, which make a variety of natural products. I have here Streptomyces coelcolor, and we work with these to make things that are important for human health and for the environment.
I'm Lou Charcuterie, I'm a postdoc in the same lab, and I'm working with a strain that produces an antiviral compound shown here. And the reason why Streptomyces produce compounds that are of interest to us as scientists is that they produce antibiotics and other sorts of small molecules as they grow in order to get their nutrients that they need to grow and to defend off other bacteria that might be trying to steal their nutrients.
And I'm Andrea Champlin, and I'm on faculty at the Museum School in Boston, which is affiliated with Tufts University. And I'm also a practicing artist myself, a painter, and I'm interested in the pigment producing capability of this particular kind of bacteria. I've heard about it and wanted to investigate the possibilities of naturally occurring pigments. And also I was interested in what it would be like to make a living painting.
Cool. And we're all interested in teaching and sort of education, and so we decided to sort of put our ideas about these bacteria down on paper, and so recently had a paper in PLOS Biology about this, and thought that today we could go over some of the laboratory aspects of that with a couple of volunteer high school students.
Hi, my name is Mario. I'm a student at Gunn High School.
So Mario, do you think it's useful to use science to approach art or art to approach science in terms of like learning about one or the other?
Yeah, I think it's important to use science to approach art because there's different perspectives and there's different things you can learn about it, and it's more natural.
What aspects about using bacteria to make art are you kind of most excited about?
I'm most excited about using the pigment for paints because it's more natural and it will replace hazardous chemicals in the paints.
What does using bacteria to make art make you want to sort of learn more about for the future?
Well, I think getting different pigments from different bacteria is interesting, and I want to learn more about how the bacteria make their pigments and how it can be harnessed in paintings.
Hey, I'm Nora. I'm a student at Castellea, and I applied for this internship because I'm really interested in how bacteria and everything, how they're all so diverse and how they do so many different things.
Do you think it's useful to try to use like science as an approach to learning art or art as an approach to learning science, and why do you think that might be useful?
I think they're both really useful for each other because you get different opinions that way, that an artist's idea on how something should work is probably very different from how a scientist would view the same thing.
What sort of aspects about using bacteria to make art are you excited about?
Well, I don't know very much about like each individual bacteria, so it seems that the whole variety of them is very interesting to me.
Okay, so I'm going to show you how to make the media in which we're going to grow the bacteria, sort of our canvas for these art pieces. So first thing you want to do is make sure you sterilize down an area. You can use any kind of antibiotic type, antibacterial type solution, and then just sort of clean off that area. And the reason why we do this is because we don't want other bacteria to grow on our place. We just want our bacteria that's going to be pigmented to grow there. And so then what you'll do is you'll heat up your media solution. This is a solution full of different nutrients that bacteria need in order to grow. And you can make this just using chicken broth and agar that you can get in a grocery store, and we explain how to do that in our paper. And once you've heated it up, then you can get your Petri dishes and open them up. And then you want to just carefully pour into your dish the liquid. It's a hot liquid. And in about 20 minutes, it'll become a solid that looks like this, which now has a surface on which we can actually spread bacteria. So if I want to actually streak out a whole bunch of bacteria on this plate, the way I would do that is to open up the plate and take my bacteria and some sort of Q-tip or paintbrush and lift up the bacteria onto the Q-tip and just spread it across the entire plate. And if you bleed this out at room temperature or in a slightly warmed oven, after several days, what you'll see is that the entire bacteria will grow across the entire plate.
Students can either work freehand or they can use images that they choose from the internet or photographs. Usually a simple image works the best, so maybe a cartoon. In this case, our student Mario chose this image. And so to do a trace image, it's good to use a black and white image because the bacteria that we paint with produce only one color. So it's going to be essentially either off or on. And so what we do is to do a trace, make sure the image is the same size, the right size for the Petri dish, and then we cut it out. Take our Petri dish, and I'm going to tape the image to the back of the dish, and Mario will be painting on using the image as a trace. These are the brushes that I'm going to use and that our students are going to use to create their bacteria art. And it's important that you sterilize the brushes to begin with. In this case we used ethanol, but you can boil them, you can use antibacterial spray. And then we have several different kinds of bacteria here that produce different colors of pigments. And another important thing to remember is that once you use a brush with one kind of bacteria, you should make sure that you only use it with the same kind of bacteria. You can see the bacteria on the surface of the agar medium, or in your case it will be chicken broth medium. And now I'm going to dip my sterilized brush it across the surface of the Petri dish. And then I will take a fresh plate and draw my image. After a few days, you will start to see an image, and your students will start to see an image. And it's very exciting to see the image develop. And our idea is that a student is more invested and more excited about an image that they've drawn, or a word, or their name, or something that they've chosen for themselves, that they have a personal connection with, that they will be very excited to see this image develop, and then they can learn about the process of how that image came into being.
So I'm painting this image of Super Mario, and I'm trying to paint the spots where it's black with this bacteria.
It's currently an archery target. I'm only using the black right now, so it's probably going to end up looking like a black circle right there, and then a larger black ring right out here.
Here I painted my name.
When the image is painted on the surface of the medium, you will take your dish, put the lid on the dish, turn it upside down so that the lid part is on the bottom, and then store it in a fairly warm place for 3 to 5 days, and you should start to see your image develop in that time, and it'll be a little bit further along every time you look at it.
We hope that we showed you some ways today to create a nexus between art and science. You can read more about ways to use bacteria in our paper, including how to actually extract the pigment from the plates and then make paint that then you can then paint on any kind of canvas or paper. And we hope that you will explore new opportunities for using pigments or biopigments in the classroom or in industry or in the art studio.